From the orbit of the Moon around the Earth, we have seen that the lunar orbit deviating from the base circle is caused by the influence of the Sun. Without this external force, the Moon's orbit would have to be perfectly circular. This principle also applies to planets orbiting the Sun. The difference is that in addition to a possible Sun too, there are other planets in the solar system that affect the orbit of each planet with different strengths and positions. The putative Sun too and the solar system rotate orthogonally to each other, and their effect on the planet differs from that of the Sun on the Moon. All this makes a calculation of planetary orbits almost impossible. From the video Physical Interpretation for the Origin of the Moon's Orbit, Real Physics, number 17, we also know that the orbit of a satellite is an oscillation around its base circle. This principle of orbit formation is also the same for a planet, although it is subject to many external forces. This means that the orbit of a planet is a back and forth movement around the base circle, i.e. a kind of oscillation. And the nature of vibration is what constitutes the quality of inertia. Without inertia, the lunar orbit, which was created by the influence of the Sun, would not be what it is. The external force is the cause of the oscillation, but the rules of the game are dictated by inertia. In different types of vibration it can be observed that the way of movement from two sides of the neutral point is basically symmetrical, although the influences of external forces for two sides could be totally different. This means that inertia in the state of motion not only persists in the present time, it also does so in the motion process of the previous vibration on the other side of the neutral point. Therefore, a regular planetary orbit, although influenced by several external forces, would also have to be essentially an oscillation around the base circle. From this aspect, that the planetary orbit forms a kind of oscillation, it can be described just from the known base circle and the eccentric distance like the simple lunar orbit with the following equation. The current position of the planetary orbit can be determined with the phase angle phi. In order to distinguish it from the previous elliptical orbit, we call it the real orbit. This formula is valid for all natural orbits around a central body. Likewise, the shape of the planetary orbit is the same as that of the Moon's orbit, i.e. the contour of an eccentric. The planet's orbital speed can be calculated just like that of the Moon. We recognize that a planet's orbit is primarily influenced by gravitational fields from all other planets inside and outside its orbit. The influence of planets outside their orbit is roughly equal to that of the Sun on the Moon. As a result, their large track axis was pulled in the length. Properly said, their eccentricity is magnified. But what about the influence of the planets within the orbit? For example, a planet A is closest to the Sun. Then an inner planet B flies past planet A. Since planet B is running faster than A, it is accelerating it. This increases the orbital speed of planet A and with it the centrifugal force. Then planet A will move slightly outwards. This effect is greatest at perihelion. As a result, its track shape will gradually become more rounded. That is, the orbital shape of a planet becomes somewhat rounder due to other planets within its orbit. More than 400 years ago, Johannes Kepler described the planetary orbit as an elliptical orbit, with a formula as follows. As far as we know, the minor orbital axis of a planetary orbit is actually about as long as the major one. Apparently nobody wants to know this fact. And the elliptical orbit is not based on any physical basis and cannot be explained physically why a planet should necessarily run on an elliptical orbit. Therefore, at least in our opinion, Kepler's first law, this says, the planets move in elliptical orbits, in one of its foci is the Sun, is not really correct. Kepler's second law, which reads, a trajectory drawn from the Sun to the planet sweeps over areas of the same size in the same amount of time, cannot be correct because it is derived from the so-called conservation of angular momentum, which is only valid under one condition, namely when there is no torque acting on the system. In reality, however, exactly the opposite is the case. The orbiting of the planet is caused by the torque of the Sun's gravitational field. Actually, Kepler didn't even know why planets orbit the Sun at all. Without this basic knowledge, an orbit can certainly not be properly described. So if this so-called conservation of angular momentum, which is a fundamental conservation law in modern physics, had any meaning at all, it would not be applicable to the movements of the planets either. When the radius of a body orbiting a central point is changed by a radial force, the body's velocity remains unchanged in the absence of external torque because, as we know, the radial force alone has no effect on the tangential velocity. Nobody wants to perceive this physical reality either. Therefore, the conservation of angular momentum is simply wrong. Kepler's third law states, the squares of the orbital periods of two planets are related to the third power of the semi-major axis of the ellipse. Expressed in a formula. According to our real orbit, the large semi-axis is in principle equal to the radius of the base circle. Given that the circumference of the planet's orbit is approximately equal to the circumference of the base circle and the average orbital velocity is equal to the base velocity, the period, t, of orbit is also approximately equal to the base circumference divided by the base velocity. Suppose the semi-major axes of two planets, they correspond to the base circle radius, are a1 and a2. Then their periodic relationship between them is the following. This results in So assuming that the circumference of the real orbit is approximately equal to that of the base circle, Kepler's third law is correct. But the physical meaning of this law from our calculation is not much more than a primitive physical knowledge, namely, distance equals speed times time. Thank you very much for your attention. See you next time.